Okay, so we're back here. We're going to do this example. We're doing prediction intervals, i.e. confidence intervals for a regression line predictor. And we're doing two prediction intervals. We're going to do it when x equals 8 and when x equals 11. So remember our model y hat was 0.865 x minus 3.811. And so we need our, let's start with A. Always a good place to start. Y hat of 8, plugging in 8, gives us negative 3.109. So if you're doing this right after before, if you're doing this right after the previous video, your list should still have all the data. It should have list 5 is your SSE, list 4 is your residuals, list 3 is your Y hat values, list 2 is your Y values, and list 1 is your X values. So this is going to help us. In the calculator, we can go to Stat, over to Calc, and we're going to look at option 2 is 2 var stats. So quit, stat, over to calculate, down to 2 var stats there. So we hit enter. We need to make sure that everything works. So if you hit enter, what it's going to use is X and Y. So our X comes from list 1 and Y comes from list 2 automatically. If you want to change your stats, you can. But all of the things we need are all based on X. And then it gives us some Y stuff. And we need some of that Y value. So you can change what lists you use by, I didn't need that, stat, down to 2 var stats. I can choose list 1 and then put a comma and do list 3. And it will give me stats on our list 3. Currently is the predictions, but I don't want that, so I'm going to quit. I just want list 1 and list 2. So I'm going to write down some of this information here. X bar we need, that's our average, that's 10.5. The sum of x, that's the sum of x sub I, we need that, that's 105. The sum of x squared, that's our xi squared. We need that, that's 1185. The S is our standard error estimate. That's not our standard error estimate, I take back. S is your standard deviation as a sample, sigma your standard deviation as a population. Our S sub E we wrote down before was 0.41744. Our degrees of freedom is n-2, so this is 8. And so we can get our, I guess we should write down alpha, 0.05. So T sub alpha over 2, critical T-score. Looking that up, we get 2.306. And so our error then is 2.306 T sub alpha over 2 times our standard error estimate, 0.41744, times the square root of 1 plus 1 over n, which is 10, plus 10, times the number we're predicting for, which is 8, minus the average, 10.5, quantity squared, all over 10, times our x sub I squared, 1185, minus our x sub I quantity squared, which is 105 squared. And when we punch that into the calculator, I get 1.043793. And then our interval is y hat, this number here, plus this minus this. This should be positive, I believe. I don't know why I thought it was negative. So this is 2.065 up to 4.153. And so this is a confidence interval. Remember, we always interpret our confidence intervals. So we are 95% certain the true value of y when x equals 8 is in this interval. And remember, the more context your problem has, if you're doing a prediction for something that's modeling a real-world problem, the more context your interpretation needs to have. Ours is very simple because we were just given x and y values, so there's no real-world explanation to have. And we can check this. So 3.10 at 9, we say it should be in this. If we look back at what our values were, the y value, I'll write in black, the y value when x equals 8 was 3.7. So it's pretty close. And an interesting thing that appears that we'll talk about more in a second is your actual value compared to your standard error estimate. If you add those, so 3.7, or if you subtract, I should say, minus 0.41744, gets us to 3.28. Now, it's not equal to our predicted value, but it's very close. And we're going to see when we do the next one, when x equals 11, that we get even closer. Because remember, this standard error estimate is, like I said, it's a pseudo average of the distance between our actual values to our predicted values for all of them, right? Not just the one. So it's not going to be perfect, but it just tells us what the average distance is. So for some of them, it's going to be real close. And part B here, we're going to see that. So part B, we're doing y hat of 11 now. And plugging that into our model, we get 5.704. Excuse me. So our error calculation does change a little bit. So it's 2.306 times 0.41744, because we're not changing. Our confidence level alpha is still 0.05. And all of these things still stay the same. They don't change because it's the same data. The only thing that changes is inside the square root here. It's no longer 8 minus 10.5. It's 11 minus 10.5. And it's 10 times 1185 still, and minus 105 squared still. That's the only change, is the 8 becomes an 11. So if you punch that into your calculator, you can do second entry and just switch that 8 to 11 or put it back in. And our error here then is 1.010991. So you'll notice it's a little bit closer. So just looking at the error difference, my guess is that our standard error estimate is going to be closer for this value than it is for that value. And we'll double check that. So our interval then, coming off of 5.74 plus and minus this, is 4.693 to 6.715. And again, it's a confidence interval, so it has to be interpreted. And the interpretation is nearly identical. We're 95% certain the true value of y when x equals 11 is in this interval. And if we look at our original data, the value for y when x is 11 is 5.2. So again, take your estimate, 5.704, and subtract 0.41744, and we're at 5.28. So we were much closer. And again, that's because the error was lower. So our regression line is closer in shape to the standard line that goes through our point here. Now, it's still not perfect, right? You can see it's still off. It's not quite exact. And it's never going to be unless we had a perfect predictor, which we did. So that's the end of 12.3. So next video we'll be starting chapter 11, which is our most difficult chapter. It uses a lot of the stuff that we've been talking about. It's hypothesis testing, but it goes into much more detail, and it's all about two populations. And so with two populations comes much more intense calculations. So make sure that you're sticking with these lectures, and if you're having trouble, come see me in office hours, make an appointment. Don't wait till the last second, because Chapter 11 is a doozy.